There we go. So again, hello and welcome to the webinar, How to Address Open Science in EU Projects, hosted by TU Wien. The webinar series Research Data Management in Austria, which this webinar is a part of, is aimed at researchers and also staff from research support services, and it serves to promote networking and exchange on the topic of research data management, such as writing a data management plan, or also various tools such as using Git or GitLab. The slides and recordings of all our previous webinars are available on our project website and also on YouTube. We will post the links in the chat later. So if you've missed any of our events, you're more than welcome to watch these on the website or on YouTube. We will also, as I mentioned, be recording this webinar, and we will be providing you with the recording and also the slides. So what have we prepared for you today? Obviously, after the short introduction from my side, my name is Della and I work at the University of Vienna. We will be joined by Michalis Dejanis from the Austrian Research Promotion Agency, who will talk to you about open science in Horizon Europe. Then we have Barbara Sanchez from TU Wien, discussing mandatory open science practices and giving you some tips for implementation. And our last talk of today will be conducted by Danielle Della and Florian Heigl from Boku University. And they will talk to you a little bit about recommended open science practices, especially citizen science. There will be plenty of time for questions after the talks. So please turn off your microphone for now to avoid background noise for the recording, and feel free to post your questions in the chat. Our speakers might get back to you straight there, but again, we will have plenty of time at the end to for discussion and to answer all your questions. So before we go ahead and start our webinar, I just want to let you know that we have 2 more events planned for this semester. They are both going to take place, or not take place, but they will be conducted in German. And the first one is about data management in practice. And the second one is about accessibility of fair data. So you can sign up for both of these on our website. And now let me introduce our first speaker of today, Michalis Dejanis from the FFG, or the Austrian Research Promotion Agency. He is working at the Austrian Research Promotion Agency since 2005. He is the Austrian national contact point for Cluster 5, Climate, Energy and Mobility, and the Cluster 2, Culture, Creativity and Inclusive Societies, as well as widening participation and strengthening the European research area in Horizon Europe, and has been a NCP since the 7th EU Framework Program. He is a member of the training team in the Academy and brings year-long experience in carrying out EU projects. Michalis also holds a doctoral degree in ecology from the University of Vienna and a master's degree in nature conservation from University College London in the UK, as well as a degree in environmental science from the University of the Egg in Greece. Michalis, please go ahead.
Thank you. Good morning from my side also. Let me do the technical stuff first. So I hope you can see the full screen. Yeah, good. Thank you for the introduction, Teresa. Yeah, I'm here because open science is a major policy for us in Europe, and we have seen several new requirements that came with Horizon Europe, which is the latest framework program for research and innovation in the EU, the 9th program that started in 1st of January 2021. And what I want to talk to you about today is, on the one side, why do we need open science? who is open science, how is open science embedded in Horizon Europe, and how it is evaluated in Horizon Europe. So just starting with why, a couple of reasons. First of all, we have here, we're in a situation where we have more than 1.5 million scientific publications every year, with a 3% annual growth, and the graph is also a couple of years old, so we are probably even more than 1.5 million publications a year. Who's going to read all this stuff? We are in a situation where we are at publish and perish. Researchers knew that they, if they publish, they get recognition, they can go further in their career. Then we had the situation where you had to publish or you would perish because others with publications and higher impact factors will get the job that you were looking for. Then we moved into not publish anywhere, but publish in high impact journals, or then you perish. And then we're here in publish frequently in high impact journals, and maybe you will not perish. So we have this unfortunate situation where anything in research is only valued according to the impact factor of the publication, of your publication list, and nothing else matters. But of course, we have a replication crisis. We have many research projects and many publications that cannot be replicated. Nobody can come up with the same results using the same methods. And yeah, there's a miracle that occurs somewhere in the process, and then you get to your results. And this is why open science aims to be a solution here to these different crises. Open science is based on open cooperation and systematic sharing of knowledge and tools, and it's grounded in the principles of inclusion, fairness, equity, and sharing, and tries to contribute on the one side on increasing the quality and efficiency of research, on accelerating the advancement of knowledge and innovation since you're sharing it early, improving reproducibility and the reuse of results, and involving relevant actors in the process as well. So how is open science embedded in Horizon Europe? It is implemented from the proposal stage to project reporting, so throughout the lifetime of projects. And they are, on the one side, mandatory open science practices, and also recommended open science practices that are good to have and are evaluated, so to say, as well. And they are evaluated in 2 out of 3 evaluation criteria in Horizon Europe, in the criterion excellence and in the criterion quality and efficiency of implementation. What are the mandatory open science practices that all participants in Horizon Europe projects need to comply with? On the one hand, the oldest of all open science requirement, open access to scientific publications, which does not mean obligation to publish. That definitely is not the case. Nobody is pushing you to publish something if you want to protect your knowledge for patenting or whatever. But if you or the consortium take the decision, the free decision to publish, then these publications, these peer-reviewed publications, need to be open access. And either gold or green open access, we'll hear more about it from Barbara. Then there's a requirement to use fair principles in responsible management of your research data, and to have open access to research data under the principle of open as possible, as closed as necessary. But all projects need to have the project and the data management plan as a deliverable by month 6, the latest, where they describe what kind of research data they are collecting, which how are they analyzing, how are they storing them, and which of those they are considering to have as open data, and which need to be protected for whatever ethical reason, data protection or whatever. And of course, these data management plans are living documents. It's not that you have to stick to what you thought at month 6. You can always change your mind. It's also a mandatory requirement to give information about research outputs, tools, and instruments when this is needed to validate conclusions that you make in scientific publications, or to validate and reuse research data. So if somebody wants to replicate your project, you need to give information, and also you need to give sometimes digital or even physical access to results if that needs to be done to validate conclusions of your scientific publications. And there is also a clause in cases of public emergency, when if you get funded by Horizon Europe and there's a public emergency that addresses, say, the area of your research, you might be required to give open access to all research outputs under open licenses if the Commission requires you to do so. Think of the pandemic crisis and research on like vaccines and so on. And if you cannot do that because you have patents and so on, you need to give access under fair and reasonable conditions to other people that want to further research on that area and use your outputs, research outputs. Good. That were the mandatories, and we hear, as I said, more about them from Barbara. And the recommended open access, open science practices include involvement of relevant knowledge actors like citizens or other stakeholders in the research, using citizen science, involving citizens and civil society in the co-creation of your research innovation program of contents in the research itself. That's what citizen science is. It involves also early and open sharing of research with pre-registration or with preprints, with crowdsourcing. Also the research management of output beyond just recent data. It can include also measures to ensure reproducibility of your research outputs, open access to other research outputs than publication, like data, software, models, algorithms. Any of those practices can be positively evaluated if you use them. Open peer review, participating in open peer review is also an open science practice. And also publishing things that usually don't get published in journals, like negative results or non-conclusory results. And the Commission has created a new publishing platform, the Open Research Europe, where such things, negative results or other things that are are not fancy enough to get published in a journal, can be published to help everybody else not knock their head on the wall from start, because they don't know that 15 other research groups have tried that and failed. You cannot find that in the literature. Yeah. How is open science evaluated in Horizon Europe? On the one side, you have to show in your proposal how the mandatory open science practices are ensured. You have to say that every publication will be open access, and if it's going to be using only green open access, or whatever measures you take for ensuring retention of authorship rights and stuff like that. You need also to explain how the recommended open science practices are integrated in your proposal, and which ones, what you do beyond the mandatory, so to say. And it's explicitly said in the template of the proposal that if you think that no open science practices are relevant to your research methodology, you need to justify why this is the case, why you don't use any open science practices. So Just ignoring it doesn't do it for Horizon Europe. And there is also a part in these forms that you fill in also as part of the template, where the publications that you use, you have up to 5 publications per organizations to show your experience and your expertise. These have to be open access publications that you use to brag about your experience so far. And I have a couple of examples from so-called evaluation summary reports. These are the feedback that you get from the evaluation process, from the evaluators to your proposal, whether you are funded or you are rejected. You get a detailed feedback on your proposal. And I chose a couple of quotes out of such evaluation summary reports. This is, for example, one from a research and innovation action under cluster 5, climate sciences area, a proposal that was funded at the end. And it says here, the proposal will provide very convincing open science practices. The proposal promotes the highest standards of transparency and openness, going well beyond documenting and extending to aspects such as assumptions, code, and data that is managed in compliance with the FAIR principles. Goes on further to say, accordingly, all scientific publications, data sets, analysis, and modeling tools developed will be made available for reuse and exploitation by others through GitHub. A comprehensive data management plan will be developed at the beginning of the work and regularly updated. So the evaluators found that the proposal was very good in applying open science practices. Maybe one reason why it got funded. But I want to show you in another example that even if you have some minor shortcomings in your open science, you still can get funded. So here the evaluators find in this other project that open science practices and research are in general very good. There are open data sets, there are open source codes, open raw model results, and so on. So it's about climate modeling, this project. However, the commitment to green open access is not total. So it says in the proposal where possible. And it is also unclear to which extent the access to models and script will be user-friendly, if there's going to be a graphical interface or just plain code text, let's say, so people cannot really, not really accessible if you don't, if you haven't programmed it yourself, if you're not that firm with code. And they think that this is a minor shortcoming, but still, as you see, the proposal was funded. An example of a rejected project. Here it says that overall, the project aims to comply with additional open access obligations, like open science principles and making data, software, and publication accessible. However, the availability of the source code of one deliverable is not specifically mentioned, and it's not clear whether this will be made freely available. The quality of commitment to open science practice is therefore not sufficiently clear, and this constitutes a minor shortcoming. I'm not saying that this is the reason why the project didn't get rejected, but you see what kind of comments are coming into projects that haven't really thought completely how to use open science. And another example is here, positively, a clear presentation of how open science practices will be adopted, but unclear to the extent to which data will be made accessible to external researchers. And expertise in open science practices and gender issues has not been adequately presented, and this is a shortcoming. This is a comment on the presentation of the expertise of the different partners. And they say that you're going to, they say here we're going to be using open science practices, but they don't underpin that with expertise in the people who work in the project. So the evaluators here criticize that there is no people with expertise, or at least we couldn't find it with open science expertise. So how are you going to be using all these practices? Do you know how to use it? Is a bit paraphrased the comment here. And it's, as I said, from a rejected RIA here in cluster 2, social sciences. So what do the open science practices actually address? They address, on the one side, early and open sharing. of results and of research, with preprints, with pre-registration of studies, with registered reports, with use of platforms where other people can, can see the steps of being taken in the research. They address research data management, and that doesn't include only open data or things that you want to share with others, but any data that you gather in the course of the project has to be managed qualitatively. They address reproducibility of your research outputs, open access to publications or other outcomes of your project. They address open peer review, and of course they address citizen and society and user engagement. And I close with a quote from Marie Sklodowska-Curie: "There's nothing in life to be feared, including open science. It is only to be understood. Now is the time to understand more so that we can fear less." So you have here also my contact details, and happy to help with your Horizon Europe endeavors. Thank you.
Thank you so much, Michalis, for the overview and all the interesting insights. There have been a couple questions in the chat, so maybe you could have a look at those and answer them in the chat, but we can also obviously keep them and address them later after all the talks. And now let me introduce our second speaker, Barbara Sanchez from TU Wien. Barbara is the head of the Center for Research Data Management at TU Wien. The center is currently dedicated to implementing repository infrastructures, automated DMP services, as well as training activities. Barbara is involved in the ministry-funded project Fair Data Austria, in the Fair Office Austria, and she is also acting as the contact point for the national node of GoFair. Within the Horizon program, she has recently been involved in a number of EOSC supporting projects. Barbara, welcome, and go ahead.
Thank you, Teresa. Thank you for this introduction. I will also do the technicality first. I think you see the full slides now. Good. So thank you, everybody. My name is quite prominent today. Sorry for that. It was some login thing. So what is my plan for today? Like the previous speaker, I would like to make a bit clearer for you where in the EU proposals open science is particularly addressed. And then I would like to make this big concept of open science a bit more concrete. Of course, with the limited time at my disposal, I can only scratch on the surface, but still I will try. So, the European Commission demands open science information and related information like research data management at a very early stage, namely in the proposal stage already. So this is a copy of an application form where they say they would like to have a description, half a page, up to 1 page maximum, of how you plan to do the research data management. Before I go into this, a side note with this slide. So this talk is a lot about data today. Yeah? So open science has to do a lot with data. I will concentrate more on the data aspect in my presentation. If you ask 5 researchers which kinds of data they generate, you will get 20 answers at least. So believe me, we did this exercise at TU Wien. What I would like to visualize here, however, is that research data being used, they're an integral part of research in all disciplines. And also software and code is used a lot in different disciplines, also apart from the computer sciences. Something else I would like to visualize here is that often researchers generate their own data, But in a lot of research projects, they work with already existing data from public data sources, from the industry. The list could be endless here. So I would like to go back to this half page or 1 page of research data management the European Commission wants to hear about. So do you think this is an easy task? I would say yes and no, because it's quite easy to fill half a page of describing which data you generate, how you deal with this data during the project. You should, however, also always include this long-term view of your data with this aspect of accessibility, reusability, costs. So in fact, what they would like to hear about are topics that are entailed in a research data management plan. So maybe you have worked with a data management plan already. This is something the European Commission demands as a deliverable, usually in month 6. 1 year ago, the Commission released a template. You can see it here on the left-hand side. However, it's a recommendation to use it. It's not a requirement. You can also use other templates. I personally find the Science Europe template on the right-hand side a bit more intuitive. But it's basically up to you which template you use. They are all about the same questions. They give you more or less the same guidance. And you can also use online tools. I have included some online tools on the bottom of this slide. What else is required at proposal stage? Not only a description of research data management, but you should also describe how you plan to implement open science practices. And this how is very important here. And we could see very well with these examples Michalis showed, that it is definitely not enough just to say, I will handle my data open science, I go for open data, but I really want to hear how you do it. So this is a slide we saw already, just a quick recap. So open access to publications is a concept many of you have probably heard about. The Commission wants you to go beyond the publications. However, they are interested that you, or they want to encourage you to also publish or make available the results underlying the publications openly, or at least according to the FAIR principles. You will hear more later about that. If possible, you should also provide information related tools and instruments. In case of public emergency, there might even be a requirement for immediate open access. I think this was the case for some COVID-related courses in the last years. So I would like to be a bit more practical now, just to give you some advice in which direction you could think when you have to answer this requirement for describing your open science practices. So in fact, open science does not apply at the end of the project or when it comes to publishing your results, but in fact, you should use collaborative platforms, automated services early on, already during the research process. So a very simple example for a collaborative platform is OwnCloud. This is a service most universities in Austria have provided in the last year. And there are some extensions to this service that allow you to also invite partners from external institutions. A very typical example of collaborative work is, of course, working in Git, either in GitHub, or many universities have GitLab instances. Ever more popular is the electronic lab notebook concept. So Jupyter Hub is a prominent example here. I have also put the example of Cybers Austria on this slide. This is a platform for data analysis in the life sciences. So, use repositories for sharing and publishing. This is a very important and essential element to actually implement open science practices. And it is not only about sharing data, but also sharing code. So again, this was a very interesting example which Michalis showed us, where the evaluator said, so the data sharing is well described, but there is no reference to code. Zenodo has got an example. So they have got a special service, which is called GitHub integration. This means with a few steps, you can also get a DOI for code if you want, and you can integrate your Git repository in Zenodo so that with one click, you get directly to the repository. There is this tool Binder where you can collect different notebooks and code. So this is very important if your data somehow relates to code. If you need code for read the data to interpret it, please provide this information and provide it also publicly. Why is a repository so important? So I would like to visualize it a bit with this landing page. This is a landing page of a data set. And foremost, with an upload into a state-of-the-art repository, you get a DOI. This DOI is essential. It's a persistent link. It means that your result stays always retrievable in the way you uploaded it. So no change is usually allowed after that anymore. So it can be trusted as a version you uploaded. And the essential thing is that with a simple link, because a persistent identifier is represented with a link, you can share a lot of contextual information. So you can share with one link a detailed description of your data set, a clear version. You can provide, if you want, the files, the data files for download, supplementary material, README files, reference to related works that can be publications, but also code again. And of course, a usage license. So this is also a very important thing you should think about from the beginning, and you should state in the proposal which kind of license you would like to provide. Another big advantage of using repositories is that you can describe your data with rich metadata, and even more so in a machine-able way. So this again enhances your visibility, the visibility of your team and of your data set. And it also enhances the understandability of your data. You should assign usage licenses. I mentioned licenses already. The thing is, once you have put some intellectual creative output into your data, the arrangement of data, the process of somehow copyright applies. And once copyright applies, you must assign usage licenses, because if there is no usage licenses, people who find your data set do not know what they can do with it. So non-licensed material does not mean it is usable. This is not always a trivial thing, because from a legal point of view, it's always the owners, the data creators, who can assign licenses. And of course, in EU projects, in bigger projects, in consortiums, there are often several creators, but you can decide together for a specific license. You just have to agree on this. This is a side note, Creative Commons license. I would like to point out that there are other licenses. Creative Commons are not the only ones. You can, in fact, also design your own license. But Creative Commons are quite practicable in the academic environment because they are about a standardized license text. They are internationally known, and they usually comply with the legal systems in our countries. And also, they are machine readable. So this again enhances your visibility, the visibility of your data set, of your team. Creative Commons, by the way, is not applicable for software. So code needs different licenses. I myself, I'm not an expert on software licenses, but I have put some links here which might be useful for you. Very important, and the European Commission mentions that a lot lately is the FAIR principles. Yeah? What the European Commission means with the FAIR principles is if your data cannot be open, make it at least fair. And I agree, this is one concept, but only one, because in fact, FAIR goes much deeper, but this would be a webinar in itself. I put you the link here. So this is an example of how you can provide the existence of your data or the context information, but not the data set itself. But people who are interested can get the data on request. So this would fulfill more or less this superficial level of FAIR. Just a short recap, because I had the red card already. So there are three concepts that appear in all these documents by the European Commission again and again, and they are overlapping, but still they are not the same. Research data management is actually the basis for the other two concepts. Open data means this data is actually out in the internet. You give it away also for further work. And FAIR is actually a deep concept, much more about it's not open. So in orange here, I have added what the Commission understands with these concepts. So research data management is mandatory. Open data is highly advisable. FAIR, with FAIR, they mean if you cannot make it open, make it at least fair. So this is my last slide already. I have got it from the program guide. Here they say explicitly, if you manage to address your open science practices clearly, so the how, not only that you do it, this will result in a higher evaluation score. If you do not plan to do any open science, explain why. And also the composition of your team, of your consortium plays a big role, because not only publications are taken into consideration, but also interesting data sets that come from within the team. So thank you. Maybe we have the opportunity to answer some questions in more detail. Thank you.
Thank you, Barbara. Now I'm gonna go ahead and introduce our last two speakers for today. Della is a senior scientist for citizen science at the University of Natural Resources and Life Sciences, Vienna. He's one of the founders of the Citizen Science Network Austria and its associated online platform, Österreich forscht. He coordinates citizen science projects since 2014. He gives several citizen science courses at the university and is a regular organizer of the annual Austrian Citizen Science Conference since 2015. He's an active member of the European Citizen Science Association and the chair of the working group Citizen Science Networks. Welcome, Danielle. Now we have Florian Heigl, who will be joining Danielle in their talk on citizen science. Florian is also a senior scientist at the University of Natural Resources and Life Sciences, Vienna in Austria. He is a founder and coordinator of the Austrian citizen science platform Österreich forscht, and he organizes several events and training in citizen science, such as the annual Austrian Citizen Science Conference. Additionally, he teaches citizen science at BOKU and provides training for researchers on how to implement citizen science in their research. His own research focuses on citizen science in road ecology. Welcome, Florian, and the floor is yours.
Yeah, thank you very much for inviting us and for having us here at this very interesting event. So I think you can now see the slides. Yeah, we now heard a lot about how open science is also understood in Horizon Europe, what are mandatory open science practices, and also a quick overview of recommended open science practices. And in our talk, Florian and me, we would like to talk about these recommended open science practices with a special focus on citizen science. What are now recommended open science practices? Michalis already mentioned some of them. Early and open sharing of research, for example. So you could share your research on preprint servers such as Zenodo, or one of the many archive preprint servers that are available currently. So just have a look what kind of archive preprint server would be available in your area of research. And if you share your research there, then this would already be one of the recommended open science practices. You can also pre-register the research plan in a public repository, like for example, the Open Science Framework, where you can upload documents, files like videos or audio files that can also be annotated by other users. You can also publish registered reports prior to data collection, if this is relevant to your discipline. You can use open research infrastructure for knowledge sharing and research dissemination. You can also take actions to increase the reproducibility of your research. For example, you can standardize and document experimental protocols to make them more understandable and also comparable. And you can also disclose negative results, as also Michalis already mentioned. You can participate in open peer review, and there are already several journals that offer open peer review, for example, BMC, Royal Society, Open Science, and so on. And of course, you can also openly collaborate within and beyond the scientific community through public engagement, citizen science, and involvement of end users. And this is what we want to talk about right now. Let's just first have a look of how citizen science, how this public engagement is understood in Horizon Europe. It is a program principle and operational objective, referring to the opening up of research and innovation processes to society in Horizon Europe. And this engagement, this citizen engagement, can range from the identification and conceptualization of research and innovation priorities, to the implementation, utilization, and assessment of research and innovation results, for example, through data collection, data analysis, discussion and publication or presenting of scientific results, and so on. Some terms that we would like to especially focus on is co-creation, because you can read this in the Horizon Europe quite often. On the co-creation, it is understood that citizen science or user-led innovation takes place, that it involves citizens or end users directly in the development of new knowledge or innovations. Citizens should be understood as individuals acting on their own initiative. So, for example, what we sometimes get, if you have a student and you give the student the task to input data into the computer, into the data system, this would not be citizen science, because your student is not acting on its own, but you would ask him to do that. It does also not refer to any legal citizenship that the people you involve in your project may or may not hold. So you can also do a citizen science project, for example, with refugees. And the engagement, also a very important word. Engagement means the involvement of citizens and the civil society in co-creating research and innovation contents. This may sound now a little bit complicated. So we thought we'd just give you a short overview of how this involvement can look like on concrete project examples. For this, we will use the white paper on citizen science for Europe from 2014 that categorizes citizen science according to the involvement of citizens. The first category I would like to talk about is pooling of resources. And in pooling of resources, usually citizens download a software that enables a project to use the unused computing capacity. And for this, a very perfect example is CT at Home from the University of Berkeley. CT at Home, it's an abbreviation for Search for Extraterrestrial Intelligence. It uses computers with internet connection to create a virtual supercomputer. So the users or the citizen scientists then download a program automatically that analyzes data from radio telescopes. So CT has a huge amount of data from radio telescopes, and it separates this huge amount of data into smaller data packages that can be analyzed through a software that you install on your computer. And this software only runs when you don't use your computer, but it's still running. So it uses this unused computing capacity when there are no other tasks at hand. Through this, CT at Home gets a virtual supercomputer and can analyze this data, large amounts of data, very quickly. Another very popular category of citizen science project or mode of involving citizens in project is so-called collective intelligence. And in collective intelligence projects, they usually happen online, and people analyze pictures, classify videos, describe videos, for example. The probably most famous platform for such projects is Zooniverse, where you can find really hundreds of such projects. And I would like to give an example from Austria, the NESCAMS project of the University of Vienna, from the Konrad Lorenz Research Center. The colleagues there want to find out how breeding behavior and breeding success are connected in gray geese and northern bald ibises. So they took videos of breeding birds and again separated them into smaller video clips and uploaded them to Zooniverse. Citizen scientists then could watch the video clips online and describe the behavior they could see in the videos. In behavioral science, this is called coding. So they coded the behavior. The most common behaviors were already given on the website, so you could just choose, if you see one very common behavior, which one of the common behaviors you saw on the video clip. If you saw a very uncommon behavior or new behavior, you could describe this with your own words. In just a little bit over a year, the project could really analyze more than 40,000 video clips, which is very impressive. Another very popular way of involving citizen scientists, especially in the field of ecology, is data collection. So usually people collect data on the distribution of animals, plants, or fungi in these kinds of projects using, for example, apps. There are really many different citizen science projects that involve the citizens in this way, but we would like to talk about our own citizen science project, Project Roadkill, from the University of Natural Resources and Life Sciences in Vienna. In this project, we would like to get an overview on road-killed animals in Austria. The reason for this is that we do have data for road-killed huntable wildlife, for example, wild boar or roe deer, but we do have no clue what the effect of roadkill is on smaller species such as amphibian species, reptiles, or also smaller mammals. So we don't know how many of these smaller animals are roadkilled every year in Austria. And therefore, we also don't know what kind of effect these roadkills have on the populations of these animal species. We also would like to create awareness in citizens for roadkill. And together with NGOs and authorities, we would like to mitigate so-called hotspots. These are areas of the road where roadkills happen very often. And how can you participate? You can report roadkills you encounter on your daily routes or your smartphone apps or website. You can upload a picture, so you can take a picture of the roadkill if it is possible and not dangerous to you or any other people on the road. Upload this picture, identify the roadkill species, give some additional information on the way, on the transportation mode you use, for example, and how often are you are on this specific road section, and then it is already visible on an online map. And so far we have collected more than 20,000 roadkill reports in Austria since the starting of the project in 2014. But people can also analyze data, and usually these people that analyze data have also previously collected data in the project, so they analyze their own data, or they can even analyze aggregated data from other users. And here I would like to give an example from the International Institute of Applied Systems Analysis in Luxembourg, also in Austria, the project PicturePile. And in PicturePile, land cover is analyzed through dedicated campaigns. This could, for example, be deforestation of tropical rainforests or also poverty. Through these campaigns, the project wants to contribute to the solution of global challenges, such as, for example, climate change or also malnutrition and poverty. And how can you participate? This is very easy. You can compare recent satellite images with older ones and identify changes. For example, as you see on the small picture on the left, this is from the deforestation campaign. You can see on the left side an old satellite image and on the right side a recent one. And if you see that deforestation happened between those two pictures, then you swipe the picture to the right. If there is no deforestation, you swipe it to the left. Through campaigns like this, global landscape data sets can really be improved, and PicturePile has now had several really dedicated campaigns dealing with many different issues, and is a very, very popular project worldwide. And with the next category, I would like to give over to my colleague.
Yeah, thank you, Daniel. I will continue in the circle with serious games. Serious games are used by researchers to answer very complex questions together with participants in a kind of playful way. So here, the very good pattern recognition of the human brain is often used for this. Next slide, please. Thanks. I would like to present an international project of the University of Zurich, which also uses serious games approaches as part of the project, because the overall goal of Crowdwater is to improve the prediction of floods and droughts and to document soil moisture and garbage along water bodies. And for this, citizen scientists perform digital water level measurements with their smartphones, or, as I said, document garbage, for example. And in the associated Crowdwater game, the reports are evaluated by all participants through reference pictures provided by the project team. And all this is programmed as a game in which the participants can collect points and win prizes. Next slide, please. The next section are the participatory experiments. And here participants are involved in the entire research process, from developing the research question to developing the methods to writing the publication at the end. And here a good example comes from the University College London, UCL. UCL founded the Mapping for Change Institute. to achieve a positive and sustainable development, sustainable improvement in the environment of citizens. So citizens come to the Institute's researchers with a specific question or problem and work together with them to design a project to answer that question. The Institute has already successfully carried out several projects, and one of it is the Lambeth Air project, in which residents of the London district of Lambeth felt that the air was getting worse in their area. So they worked together with the researchers from Mapping for Change to develop a method for measuring air quality, collected data and took the data to the authorities to demand an improvement in air quality based on scientifically valid data. Yeah, and here anyone can continue to initiate such projects simply by writing an email and being willing to work together to develop and implement a project in this institute. And the last category is about do-it-yourself projects. So projects that are started and carried out without the involvement of scientists, or where scientists only join in towards the end of the project. And here a very impressive and dramatic example is the Safecast project, which originated in Japan in 2011 after the devastating earthquake with the tsunami and the accident at the Fukushima reactor. Back then, it was not possible for the local population to obtain reliable data on radiation exposure. Both the Japanese government and also the operating company TEPCO did not release any data, and people were naturally frightened. So 3 people then started the project Safecast, in which they built simple Geiger counters by themselves, put the plans of the Geiger counters on the internet, and also the measurements they took with these Geiger counters. And quickly the blueprints spread and people built their own Geiger counters all over the country, took measurements, and for the first time were able to make an informed decision about whether they could stay or should leave the area. Scientists looked at the data afterwards and declared it valid. So today, people all over the world are uploading local radiation exposure data to the internet so that others can again do their own analysis with it. So this is quite a huge project right now. Yeah, and these were just a few examples of how citizens can be involved in a scientific project. And in the following slides, we shortly compiled an overview of citizen science projects that have been funded on a European level so far. And as you can see here, there are some projects about citizen science, how citizen science can be used, how citizen science can be institutionalized, or what impact citizen science has. We linked all projects for you, so we will share the slides afterwards with you, and you can have a closer look at the projects by yourself. The next slide, please. Currently, the focus of the funded projects is on environmental issues, and different factors here are monitored, such as air quality, odors, impact of climate change, or birds in gardens, for example. There are also projects in the technical and humanities disciplines, but we only found 2 in each. And one important Horizon 2020 project regarding citizen science is also on the next slide, please, the EU Citizen Science Platform. EU Citizen Science acts as a knowledge and community platform. And on this platform, you will find some of the projects we listed before, but also information about citizen science, guidelines, specifically produced MOOCs to support learning about citizen science, and much, much more. On a European level, there is also an association for citizen science, which can be very useful for you. The European Citizen Science Association serves as to connect all European actors in citizen science. There is a conference every 2 years, and this year it's in, Danielle, please correct me, in October, I think, again. So the registration for this is open and you can go there in Berlin. There are also working groups on different topics in citizen science within EXA. So this is a very important association for citizen science on a European level. And the next slide, please. There is the link to the European Citizen Science Association and also the different working groups. And as an example for national initiatives, we would like to present our own platform in Austria, Österreich forscht. We take this example because we know it quite well, and other national initiatives are structured quite similar as ours. On our platform, you can find all citizen science projects in Austria known to us. There is a community-led blog with lots of news and information about citizen science. And also in Austria, there is a national citizen science conference happening every year. And the next one is already in June. And registration is still open until tomorrow. So please also visit us in Dornbirn in Vorarlberg in June. Yeah, and as you can see here, similar platforms already exist or are currently under development in numerous countries. Feel free to contact us, Danielle and me, via the EXA working group or via a platform in your country, or have a look at EU citizen science, where many platforms are already listed. So there's a lot out there regarding citizen science, and the community is happy to help you with your project idea. And in the last slide, we have also listed links and publications for you, because there is a lot of literature out there on citizen science. There are 2 open access books which were quite recently published, the last one last year, based on a cost action on citizen science. Yeah, and with this, I would like to close our presentation, and thank you for the attention. Please feel free to ask us questions now in the discussion part, or send us your questions or comments afterwards via email. Or of course, we also invite you to follow our YouTube channel or on Facebook or Twitter to stay up to date and stay in contact. Thank you.
Thank you so much, Florian and Danielle. I'm going to stop the recording now.